guys, been getting a lot of questions on Facebook and Reddit in regards to my immersion setup for my Asic miners. This immersion setup is actually running one Asic miner. I know there's two there, but I'll explain why that is in a moment. A lot of people have been asking what materials to use, what type of radiator, how big, what type of fluid, a whole bunch of different questions, so I'm going to try and clarify that up for you. I've turned down my fan temporarily. I know my heat of my fluid is already going to go up, so normally my fluid runs at about 40.1 degrees stable, but because I've just turned the fan down to make this video so you could hear it, that's going to go up fairly quickly. So I guess we'll start quickly from the panel. I'm not sure what stage most of you at, but I've wired in to the panel two 20 amp 240 volt dual pole double pole breakers. So wired them down to here, and they have surge protectors on them. And then I've just run the secondary one because the S19s actually have two 220 power supply requirements, so I had to add another extension of the circuit. If you quick rundown of, make sure you stay in the 80% rule. These things consume a lot of power. So the S19, you're looking at approximately 3100 watts of power. This is an Avalon 1246, 85 terahash. It runs a little bit more power at about 3400 watts. So just make sure you stay within your, when you're wiring your box, just make sure you stay within your safe 80% rule. So that's just basically your amps times your volts, and then 80% of that would be your safe amount of wattage you can pull from the receptacle. So for example, this is 20 amp 240 volt double pole breaker. So if you multiply that, you get 4700, and this will be consuming about 3100, and the other setup will be consuming about 3400. So 3400 to 4700, I'd be within the 80% rule, just to make sure you're not going to get any overheating or make it unsafe. From the wall, now absolutely got to give credit. I first got this idea. There was a guy on Reddit, Anthony Larson. He has a very similar setup. I basically used the foundations of it and then modified it multiple times to get to the end state of what we have here. So big shout out to him for getting me started in this. So basically the tank I'm using, and I'll try and even measure it as we go along, so this might be helpful to you. For your miner size, a lot of people are running S19s. With this setup, I have a hot-cold divider, and I'll show you underneath. I actually have two flow control plates that come straight up the top of the miner. I just got to increase the fan a little bit here. Just a little bit of heat. So that essentially pushes the fluid up through the miners, over the waterfall into the hot side. Pump then pumps it up and through the radiator. All the heat's dispersed out the front of the fan, through the front of it's a hydraulic oil cooler, and then it gets pumped down back underneath where there's a T, and it directs it into two flow control plates, so it equally comes up and through both of the miners. And then if you had a thermal camera, you could see that the heat just dissipates, comes up over top of the grills and pours into the divided side. So how I've achieved that, it's actually called the chimney effect. So there's a video on YouTube you can look up, and it's just basically when you put a cylindrical tube over top of a flame, it's going to transfer that heat upwards, and it's going to force the heat to come straight up to wherever you're guiding it. And so basically this works the same way in dielectric fluid. It comes up and through the grills, through the PCB boards. It has nowhere else to go. I have the top of these miners, you can tell, are just 1/2 inch above my top top of the divider plate here, so that way when that's full, it's got to be higher than your waterfall, and then it's going to drop into your hot side, so that gives the fluid just enough to disperse over the top of the grills and the miners. These are sitting nose down, by the way, and flowing into the hot side. The hydraulic oil cooler, this one in particular, is a AH1470T-CA model, and through testing numerous different pumps, numerous different failed flow attempts on what's optimal, plumbing, I've changed from 3/4 plumbing to 1-inch plumbing. This chimney effect is essentially the most optimal way of heat transfer, and it truly is cool to watch, and it works really, really well for heat dispersion. You're not losing any of your energy in the process. So this specific rad, there's not much information out there on how you need to size your rad for how much heat you're putting out in wattage. And if you look at the numbers online, they don't actually make sense. So you would think that, for example, I believe this had a rating of about 77,000 BTUs cooling capacity. And if you combine both of the miners, on paper it appeared that they would have the equivalent of about 22,000 BTUs. So I'm like, okay, I'll be good to go for both of them, but it doesn't actually translate that way. For whatever reason, you're only probably going to get about 15% cooling capacity on what's rated. So what I've been able to figure out and achieve stable temperatures through is this here is rated for about 18,000 kcals an hour, and just as a safety window, I ran both of these units, and I can basically run them at 40 degrees dielectric fluid temperature, and the PCB boards will each be within 1 degree at 65 degrees of inlet temps, and then 55 degrees outlet temps. So I'm really happy, stable temperatures when running one miner. The reason why I'm actually likely going to sell this unit is because this setup just simply isn't big enough. This is just simply the hydraulic oil cooler that's not big enough. I'd need to order a bigger one. I'd have to wait for a month, bring it in from China, and then replumb everything, and I'm just want to take a bit of a break from it. So what I'm going to do is just keep my S19, and there's overclocking firmware supposed to be coming out within the next couple of weeks that I can bump up the speeds a bit, and I'll just make some slight modifications and just run one miner in immersion cooling. So what happens when I bring both of the units, when they're hashing fully, bring them fully up to temperature, I get a temperature of 52.1 degrees, and it basically puts these boards at about 77 or 78 degrees, and it's just simply too close for comfort. The most your average maximum PCB board temperature is only supposed to be 80 degrees Celsius. So when those temperatures started climbing up, I just opted to just shut down one miner and not run it. So the cooler's not big enough to run both, but it runs absolutely one perfect. So yeah, I'm getting super good temperatures just running the S19 right now. So that's why I kind of gave a rule of thumb. I told a few different people online that I'm confident in saying that if you have a hydraulic oil cooler where the fan capacity is, or has a cooling capacity of 18,000 kcals an hour, you can pair that and safely disperse the heat from one 3500 watt Asic Miner. So basically, if you're running two of those, then this is a 200 liter minute version hydraulic oil cooler. You can get 400 liter minutes, 450 liter minutes, and those will do double or more. So I would probably do something like 40,000 kcal. There's a model that'll put out over double the heat dispersion. That way you're going to be in a safe zone, and you can run them safely. All right, so one thing, apologies if I got sidetracked there for a bit. This tank is 18 by 18 by 19 inches high. Look at that, 19 inches high. It is glass. And then inside I used polycarbonate, and the hand custom built all the different things inside, flow plates and dividers, and then I used E6000, which I've used for many years, and it's awesome. So I used E6000 to glue everything into place. It's a bit time consuming, a little bit tedious, but it turned out really good, and everything's holding up really nicely. I have a lot more pictures I can share with you during the building process of the tank and full plate and divider, and kind of how I designed that. For the fluid itself, we got, I'm using BitCool 888 fluid. The tank holds 91 liters, and I have 80 liters of BitCool, and I'm running currently about 75 liters of BitCool in this whole system right now, and that's a good amount. So this tank size is definitely a really good size for two, like S19s for example, if that's what you're running. If you're wondering what this setup here is, I'm in Canada, in northwestern Ontario, so we get, an average of minus 15, minus 20. Some mornings are, minus 30, minus 35. So it's just an easy way that I can dump some more air on top of the tank. I'm normally pump this up a bit, and just by chilling the top of the tank, it was minus 32 this morning. I had a fluid temperature of 30 degrees, so it was down 12 degrees, and my PCB temps were in the mid 50s. So that's just a little bit of experimenting around, but it actually does make a big difference when I'm getting free nature's air conditioning from outside. So not necessary, but that's something that you can also use to bring your temperatures down a little bit. Okay, so basically once you have your miners in and your flows directed the way you want it, you're going to want to get some type of pump for your hot side. You're going to want to pump that out. Now there's many different pumps, like you can get, I'm talking Canadian dollars, but I'm sure, around $100 American. You can get a lot of different pretty decent pumps for that. I opted to go with the Asic line, I believe that's how you say it. They're Italian. The reason I have 3 of them is through trial and error, trying to figure out which one is going to work the best for me. So if anyone needs a pump, I got a couple extra ones here. This one will work fine. Ultimately, I ended up going with a little bit of a bigger one. Not entirely necessary, but it's a good pump, and you can see that you're getting up to 2,700 gallons per hour. This other pump, which would also work fine too, you're getting 1,321 gallons per hour. And then this one, which would also work fine, probably if you had like a 1 miner setup, you're also getting 660 gallons per hour, which in a lot of applications that's totally fine too. The reason I went with these pumps, they're definitely more expensive, maybe 2.5 times more expensive than your average pump, but they're Italian built and they have a ceramic internal. So for me personally, I don't like cutting corners. When you got 20,000 American and Bitcoin miners in your tank, I don't want my pump to fail and for my system to overheat, because that could cause permanent damage and get super expensive. So that's why I've opted to go with expensive pumps. We'll see how that pans out in time. Okay, we'll talk a minute about the base plate. You see it's made out of 2x6s. I just made a base plate that went around the back of the tank. I just custom built that out of 2x6. I stacked it 2 high, and then I screwed those boards together, painted it white, and I made it just so I could bolt the hydraulic oil cooler on a stable platform so that I can do my plumbing off it, because you don't want to have that moving around. When you're doing your plumbing, now I'm just a DIYer. I don't have any expertise in really any of this area other than just putting the reps in the last few months and figuring everything out. So my neighbor is a plumber, and he's definitely given me some helpful tips and what to use, and it's helped me a lot through the process when I had questions. And so when I first did these joints in 3/4 inch plumbing, right now I'm running 1 inch plumbing, dielectric fluid really has a way of finding its way out, and you'll definitely get a little bit of leaky seals if you just use the white tape. It seems no matter how good you tape it. So what I ended up doing is you use gas tape, because the threads are a little more coarse. Now you can use all brass. This is just because they didn't have the, I used Gelb here because they didn't have the size I was looking for at the time, so I just opted to use Gelb. It's not a big deal, but brass is a little bit better, of course. So you're gonna need 2 ball valves. These are 1 inch ball valves. This is 1 1/4 on this unit, but some are different. Some are 1 1/2, some are 1. So you just got to get whatever fittings you need to go up or down to the size of your plumbing. So I did have 3/4 inch poly plumbing, which worked fine. I am a little bit happier with the flow rate from the 1 inch plumbing though, so I changed all the plumbing. Just poly piping. You cut it with the X-Acto knife and use hose clamps to secure all of your pipe on there. Now you can use PVC or you can use poly. Either is fine. The PVC is going to be a little bit thicker, a little bit stronger, so that's going to let you tighten your clamps a little bit tighter and kind of give you the warm and fuzzy, then they're going to bust on you. But honestly, either is fine. I just ended up ultimately going with the PVC ones in the end. I mean, you could do your whole thing out of copper piping too. It's just really, I would suggest if it's your first build, just use this because it's easy to cut and modify. If you make any mistakes or have to rejig it, which you probably will, so I would recommend using this for your first build before you get carried away with copper plumbing. So sorry, anyways, as I was talking about on the joints, you're going to want to use the yellow gas tape, and in conjunction, after you tape it, give it a few, 3-4 good wraps. It's a thicker tape than the white tape, and then you're going to use this Mega Lock all-purpose thread sealant. I know it looks mangled, but again, it's Mega Lock all-purpose thread sealant. It's blue, and then you just goop up your joints after that. And then when you're tightening these, another thing I've learned over the course of this project is you're going to need 2 really big, really big pipe wrenches. So you want to get these fittings super tight. You don't want to leave any extra play in them. You're not going to break them. You can put these super tight, and using both sealants, you won't get any leaks. It'll be blowing dry. Another thing about this hydraulic oil cooler, a lot of people ask about noise and everything. I have it turned down now, but it's like one medium-sized fan running when it's running at full tilt. It's not super loud at all. Most of them aren't going to come with any plug. This particular unit is 220, so I had to wire. I just took an extension cord and I just wired my own plug into this top part that comes with the unit. So then I wired that extension cord into a step up or step down transformer. In this case, I'm going from 220 stepping down into 110, and then I have a fan speed regulator here that lets me adjust the speed of the fan, just so you can hear it going up or down. You can usually only find these regulators in 110, so it's a good way to do it. Sometimes these units will come in 110, the smaller ones, but most of them are only going to come 220. And those are primarily out of China, but you can get these a lot cheaper out of China than you can out of the United States for a similar product. So I would recommend finding a good supplier from China, and then you can really customize and get whatever size you need from there. And they are really good quality. It's a really heavy duty unit. I also have an Inkbird temperature sensor hooked up, and you can see that's the C929A smart Wi-Fi controller, and basically it's just going to give me a loud app indicator. It'll start giving me an alarm if the temperature goes over a certain temperature that I have it set for. That basically will allow me, if I have some sort of problem with my immersion setup, it'll give me an alarm, and then I can come fix it. Or worst case scenario, I could even run home from work and come fix it quick, just to make sure we don't get any overheating problems. So I would highly suggest you put in a smart Wi-Fi controller for monitoring. Even some basic stuff, like I just strung kind of like half-assed, but a couple of extra lights in here just so I get a ton of bright lighting in here. Here's for the room temperature. It usually just sits around 80 degrees. Now we're in the winter here. I'm basically supplying free heat to my house, and it works great in the winter. In the summer, I'm just going to come over top of here with a shroud and some ventilation tubing, and I'm just going to feed it right back out this basement window and get rid of all the heat in the summer. So yeah, it puts off quite a bit of heat. These are like essentially like two big space heaters, but running one is still one space heater, so you're going to need a way to get rid of the heat if you're living somewhere hot. I'm trying to remember if I have covered everything or not. Yeah, I think I've pretty much covered everything that you need for the system. Again, you just need to run it on a cooling system loop. So you got to pump it doesn't have to be obviously this fancy waterfall type setup. I would recommend doing it because it's super efficient, but you need somewhere to pump your hot fluid out of. So I can put it at the bottom. Normally, obviously, heat rises. You might need your pump somewhere else higher for your setup, and you have the cool fluid coming through the bottom, but you need a way to get your hot fluid out and your cool fluid back in. So obviously you pump it out through here, goes through the rad, and if you put your hand here, you'll notice it's quite hot, and then here you're going to notice a significant reduction in temperature for the fluid going back into the unit, circulating it through the flow control plates, and then coming straight up through the PCB boards on the Asic miners. Oh yeah, okay, one other thing that I didn't mention. When you immersion cool altogether, you're going to need fan spoofers. There's going to be 4 individual chips for the 4 fans that connect to typically any of these big Asic miners. So this Avalon, I managed to find these on eBay. They're fan spoofers, or simulators they're called. They're the same name for both. And then these ones are actually on the top of the unit, connected directly to the board. So they're all tucked away, but there's another 4 units. This one in the front, and then on the bottom you'll see there's 2 down there at the bottom. So those are going to trick the fans into thinking that they're running, so then they can run immersion cooled, or else they won't work. Another thing, then obviously you need to remove your fans, because you can't run them underwater. There's too much resistance, it'll mess them up. You can, like these are running right now, you can run the power supply unit, or PSU fans. They're small enough that they're fine to run when running in immersion cooling. So you can leave those in, because it's a much bigger process to try and disconnect and trick those fans into running to make it work. So you just need to get fan spoofers, remove the fans, and that's basically essentially it. Then you're ready to dev them. And okay, so last thing, really quick cost assessment. I understand a lot of stuff is cheaper on the whole United States, so you could probably do this a lot cheaper, but I'm just going to give you a ballpark of me first time doing it, not cutting any corners. Just wanted to get it done. I wanted to use good materials because I didn't want to have any problems, because problems can lead to damage to really expensive equipment. So that's my logic behind it. So you're looking at this unit here. Shipping was a big factor in the price. You're looking at about 700 American. You know, you can add another easy 150 bucks probably for your plumbing. The tank itself. Oh, and by the way, this is a glass tank. I would recommend using an acrylic or polycarbonate tank for the entire thing. If I was to do it again, just that way you could feed your pump through the bottom of the tank or customize it a little more. So glass is just obviously a little more fragile, not as strong, but yeah, that would be my recommendation. I would use polycarbonate or acrylic if I was to do another build. But so far, it's working fine. So that tank, I believe was $220 American. My custom fabrication with my polycarbonate, that stuff's actually fairly pricey, so you could probably add another 100 bucks for that. Miners, obviously you guys know what those go for, like 11.5 for an S19J, and you know, 8,000-ish for an Avalon 1246. You can definitely add, you know, 300 bucks easy for all the stuff you're gonna need for electrical. And that's a lot of the stuff. Sometimes you got to wire your own plugs up and everything because they don't come with the right plugs, so that can take you a little bit of time, and just figuring out what type of plugs you need for 220s and stuff if you're not familiar with electrical. So you can always ask me any questions and I can save you some time that way if you have questions about electrical or any of this stuff. 180 bucks American per 20 liters, a bit cool. Then you're gonna factor in probably in the United States 100 bucks shipping. To Canada, unfortunately, it was about $300 to ship that here. So yeah, the dielectric fluid is a big expense. The fans, entirely not necessary as part of the unit at all. And then just other like basic stuff. So you're talking about you know, temperature sensor here, maybe that, you know, 50 bucks, 40, 50 bucks for that. Just a power bar, you know, 20, 30 bucks for that. The step up transformer, you can probably factor in, you know, 60 to $80 ish for that. Fan speed controller, you know, 20 or 30 bucks. And then yeah, your pumps. So the final pump that I went with, this was like 480 Canadian, so you're looking at probably 350 American, 3 to 350 American for that. You know, if you step down, you're looking at probably 2 to 250 American for that. Would really recommend these pumps, though. They're super quiet, and they do have a 5-year warranty on them, so they are a good pump. And I think I'd mentioned earlier that they do have ceramic internals, which makes them a good high quality build. So a little more pricey, but they you get what you pay for sometimes. And factor in a little more for your customization and your wood and whatnot. You know, miscellaneous cords and, you know, Ethernet cables. You got to just factor on the little stuff. It always adds up quick on you too. But yeah, so I don't know what the tally is off the top of my head. I definitely know I have you know, probably $3,000 in the setup. So can you do it for cheaper? Probably, but yeah, that's my immersion cooling setup. I hope you enjoyed.